Right, you see, we have three main different type of, I can say, communication in networking. One is one-to-one communication, which we call it as point-to-point communication. The other one is one-to-any. We don't know how many. It is any. That one-to-one we call it as unicast. That one-to-any we call it as broadcast. And then we got multicast, which is nothing but one to a group. One to a group, which is multicast. You see, we understand what is unicast, sending to one particular destination. We understand what is broadcast, sending to a broadcast address which will take to anyone in that broadcast domain. But this multicast, when we say one to a group, which group? What identifies a group? These things we need to understand. Unicast, we know the destination to which you are talking. Broadcast, you know you are talking to anyone who receives the packet. But multicast, we need to tell the group members. Now, to identify the group, we need an address. Every individual computer has got an address. We call it as unicast address, the host address. Every single port on a router has got a unique address. Every single computer has got an address. So that is unicast address. That's a host address. Now, when you say multicast, talking to a group, to which address we are going to talk? On top of the address, the host address, the individual address, we can assign a group address using a protocol called IGMP. Internet Group Management Protocol. Using this group management protocol, we can give a second address for the device that wants to be the part of group. Multicast addresses are to identify a group. Multicast addresses are not the primary address of any device. You need a host address which is already there on the interface. This is on top of it. It's like a secondary address. Multicast address is an optional one. But unicast address for a device, the host address is mandate. You cannot have a multicast address without a unique host address. So now when we say multicast address is helping to group, identify a group in a network, what do we mean by that? See, you may have a computer in 10.1.0.1/16. Now, you see, if I want to communicate only to A and C, I can put both of them in a group. Using a common multicast address, let's say 239, 239, you see, these PCs A and C have got their own individual IP address 10.01, 10.3.0.1. On top of that, they also got 239.111. So if there is a traffic that need to be sent to both, I no need to send to individual. I no need to send to an individual IP address. I can simply use this multicast address. I repeat, if I want to send a packet from alpha, which is in 10.10.0.1, to both A and C. If I want to send a packet to both A and C, all that I need to send is to this address. Only A and C can receive it. What is the advantage? Advantage is I'm sending a single packet which is going to both. If I don't have multicasting, then I have to send from here a copy to 10.1.0.1, another copy of a packet, same duplicate packet to 10.3.0.1. 2 times the bandwidth gets increased. More CPUs on the processing routers in the middle. You see, I just got 2 destinations. What if there are 100 group members? With unicast, you will duplicate the packet 100 times, and to 100 destination, you have to send the packet. The routers need to process the 100 destination and 100 packet. Whereas, when you send to a multicast address, the packets are not duplicated, just one packet going from the PC to the router. And the router is seeing that A is connected to the interface E0, C is connected to interface E1, Now the router only duplicates it 2 times and send it to this router beta, and beta will forward the packet here and gamma will forward the packet here. In a large network, this maybe many routers in the middle, they only process one single packet, not 2 packets. Only when there is destination in 2 different directions, the packets get duplicated and sent in each direction. If not, even for 100 100 computers, 100 destinations, one packet only. Let us say I want to deliver the packet to A and B. Now also, only one packet is sent, one packet is sent, and this router will duplicate it because A in this interface and B is in another interface. But up to here, it was single packet processed, single bandwidth utilized. You see, I'm trying to explain you the advantage of multicasting. If no multicasting, what you would have done? Unicast. You would have sent the same packet twice because you have 2 different destinations. Or you would have done broadcast. The problem with broadcast is everyone will receive it, not only A and B, even C and D will also receive it. Also, bandwidth, CPU. They're all getting wasted in different routers and links where there is no one to receive. So what I'm trying to say here is broadcast is also bad. Unicast is also bad when it comes to communication between group of device. When you're planning to talk to more than one, when you're planning to talk to a group, don't do unicast, don't do broadcast. Broadcast will take to everyone, including those that need to get. But the problem is those people who are not supposed to get, they also get not secure. Unicast is consuming more CPU and bandwidth. So here we understand where to use multicasting and the advantage of using multicasting. Whenever you got group, you use a common group address called multicast address. And using IGMP protocol, you assign this address. Now, we have seen the use case of multicasting. Now we're going to see the dedicated range of address that are meant for multicasting. Class D. The range is between 224 to 239. These address range, this range of address, anything starting 224 or 225 or 226 up to 239, those addresses are multicast address. A lot of multicast addresses are already reserved. For example, 224.0, 5 and 6 OSPF, 224.0, 18 HSRP, 224.002 routed mode multicasting, 224.001 host only multicasting. So a lot of addresses are already reserved by various applications protocols. But this 239 range is free for you to use. 239. So here you have the list of reserved. So this base itself is reserved. So don't use 224. For various protocols, it is reserved. 224.0.0. 12. We are going to learn about PIM in multicasting, which is in 13. Yep. So that base 224 don't use. You can use 239 easily. I can't remember all these things, but one thing you can remember that 239 is available. All these reservations you cannot remember, but there are reservations. Okay, so in our example, we will be using 239 in the first object. These addresses, starting from 224 to 239, you cannot assign to a NIC card. You cannot assign to a particular port. Try assigning, it will throw error. It can be assigned only by using IGMP. So we got a dedicated range for multicasting as per the standard. If you use this range, routers will understand that this is a part of a group. What is next? Next is, you see, this multicast works in two different styles. One is shared tree, another one is source tree. This source tree, we call it as dense mode. Shared tree, we call it as sparse mode. Two type of mode, dense mode and sparse mode. Source tree, shared tree. But nowadays, we don't see this dense mode supported because it's not a good approach. What it is, first of all. Let's say this is the source of multicasting. Let me copy this to another location. Hmm. This is the source. What this source will do, it will flood. When it floods, everyone in the topology will be able to receive, but not everyone can open it because they don't belong to the group. See, it's a multicast traffic. The source is sending to 239.1.1.1. But the packet is flooded from the source to all links, to all devices. These devices will not process it because they don't have membership. They're not member of 239.1.1.1. Only these two accepts it. So what happens here? This will say prune back. It will say, hey, prune back. Don't send me. Prune back. No one is there to receive it. Prune back. Prune. This is what we call as dense mode. Flooding and pruning. Pruning after knowing that there is no one to receive. But the problem is, it is not pruned for all once for all. Again flooding will happen, again pruning will happen, again flooding will happen, again pruning will happen. This is unwanted bandwidth here and CPU here utilized. This is what? Dense mode. From the source, it is trying to form a tree. To know the branches, it is flooding. Wherever the flooded packet is received, the tree gets formed. On the other branches, it gets pruned. So according to this 239.1.1.1, the multicasting, this is the tree portion, the tree with two branches, because the other side is pruned. See, so the pruning happens not just once. Every time when the flooding comes, the pruning will happen. Whenever a multicast traffic is sent by the source, the flooding is going to happen, and again the pruning is going to happen. This method is not uh, currently in latest devices. It's removed. It is removed. This dense mode approach is removed from multicasting concept. Nowadays, no device, the latest device, they don't support this dense mode. You don't have an option to enable it. It is good that they have removed it. Now, the other mode is called as sparse mode, which is a shared tree. Sparse mode. What is sparse mode? Sparse mode, the load has been shared with a mediator. Sparse mode, with the help of a mediator, the source will know the destination. With the help of a mediator called rendezvous point, with the help of rendezvous point, the source will know about the group members, and the flooding will be done only on those links where the group members are. For example, if I make this as a rendezvous point, this guy and this guy will use this link and come and register here to the rendezvous point, saying, I'm a member of 239.111. Now, rendezvous point knows the receiver's whereabout, receiver's location. So, when source comes, the S comma G is known. Source and the group member for the source is known. As a result, the packet is sent only in this direction, not here. For that, what is important? A mediator, a meeting point, a gathering point, a rendezvous point. This is what we call it as sparse mode. In dense mode, no rendezvous. In sparse mode, you have rendezvous. Fine. Now, what are all the things involved in this multicasting? Number one, to join the group, I told you, you need IGMP. Now, to carry the multicast traffic over the link in the path, you need PIM, Protocol Independent Multicasting. You need IGMP, you need PIM. Without these two, multicasting is not possible. PIM is to show the multicast enabled links paths. IGMP is to join the multicast group. Right, so what all we have learned? We have learned that sending to a group needs a group ID called a multicast address. To join a group, we need a protocol IGMP. To carry the multicast traffic on all the links wherever you want, you need to enable PIM, protocol independent multicasting. In multicasting, there are two modes. One is sparse mode and the one is dense mode. Sparse mode is popular. Dense mode is not because it is flooding and pruning. In our lab, we will be seeing both. Do you have any question on this theory part of multicasting? Rendezvous point. Right. It's not an English word. Gathering point. All right. Any other question? All right. So